Interactive side. Test-driven development.
Test-driven development.
The floor is yours, Josh.
All right, so my name's Josh Freeman. I'm a software developer at Grok Interactive. And a little bit of background. So when I was hired about a year and a half ago, I was hired on to take on a PHP project for Grok. And this was basically an event management system. So you create events, you have people attend them, you invite people. It was an event management system, quite similar to the Meetups.com, but much more involved. And so I'd always liked the idea of testing, and when I started the project, I went from a test-first approach that I've been bitten so many times by not testing. And we got to a point where we had to go so quickly, and the tests were just not working out. They were so cumbersome to write that it was slowing us down too much, and we couldn't get things shipped and out the door, that we abandoned tests altogether. And you can get away with that for a while, especially if you're just one person that knows the entire code base. You can get away with it. But when you start adding developers, that quickly becomes unmanageable. And we got to a point about 4 to 5 months into the project. And by the way, Ryan was with me on that fateful project.
On the project at the time.
Yeah. That we got to this point where we had so much complexity in the project and so much debt that was unguided by tests that we could not move. We couldn't add things, we couldn't remove things, we couldn't change things.
How many were working on it?
I think at the peak there was about 4 or 5 people, and any change we made would be certainly met with pushback from the client of things that this change did this, but now you got to fix these 2 or 3 other things. And we made a lot of pivots in that project, but I think the most important one was the adoption of the command query separation of how we approached the application. And by separating this out so the command query responsibility separation, you have 2 types of functions, and this really is a functional thing, where you have a query that when you execute it, it returns the same result back every time, but has 0 side effects. So no matter how many times you call that query, nothing else about the world will change. On the other hand, you have commands where you tell your application to do something and change state somehow, or whatever side effect that may be. But you never rely on any return value from that. You aggressively separate out queries and commands. And when we started to do that, that then enabled us to have an easier approach to testing. And over the course of 2 to 3 months, as we began to migrate our system over from the traditional MVC approach where everything is shoved into your controllers or models, and then separate that out into a more structured application that has tests behind it. Then when you had something change, I mean, we've all had something where, I'm going to make this one change over here, and something completely unrelated, seemingly unrelated, breaks. I mean, we've all done that. When you have a strong test suite, you can help mitigate a lot of those moments. And so testing is a very, very important thing in application development. In my opinion, it is unprofessional to write software that doesn't have tests behind this. That idea is probably most popularized by a man named Bob Martin. He's the TDD guy and he's the guy that coined the acronym SOLID. And when you look at object-oriented design and testing, they go hand in hand. Tests that are easy to write almost always lead themselves to be better object-oriented programs, and vice versa. That object-oriented programs lend themselves to be easily tested. And so, by doing that, if you have something that's easy to test, typically you're going to have small units and small components that are composable and reusable, and you're not going to have these big balls of mud that you find yourself with. So as I get started with this, feel free to jump in and ask questions. If I'm going too quickly, just ask me to slow down.
Josh, I did want to, excuse me.
Yeah.
I think it seemed like you said there was a major breakthrough when you guys developed this methodology of separating queries
Right.
that do not change the state of anything. And then you had commands which do change state. Is that what you said?
Right. So it's the difference between asking a question over and over and over again, and then telling your application to do something, and not having, not relying on the response of that.
And you separated. You said something about not jamming everything into a controller.
Right. Right.
So
So-
does that mean you're physically, or there's a separation?
Yes, there's
Yeah.
absolutely a separation.
And it's like having a getter function versus a setter function. Your
Okay.
getter is the query. Your
Okay.
setter is the command.
Okay.
And that's on a function level. So a command and query separation, that's more the class level, like a handful of commands.
Yeah.
Related queries and a handful of commands that are related commands. Or a handful of basically setters.
Yeah.
That
This
are
is the
changing
first
state.
time I've heard this distinction, which is really makes a lot of sense.
So
It
in the model view controller paradigm that we use, you have the controller that when you talk about in academic terms, right? You have the controller that accepts some sort of input and then translates that input into some model behavior that then goes back and notifies the controller, who then who presents a view that goes back to the user, right?
Right.
Well, you have the controller, and so the controller is only supposed to be a translation mechanism, whether that's over HTTP, whether that's a terminal application, whatever the delivery mechanism is. This is just supposed to translate information to your model. Well, when we talk about models, especially with the advent of Ruby on Rails and Laravel and things like that, you're almost always looking at the model as just being some sort of active record, like persistence entity. And so between these two, where does the logic go? Where's the business logic go? In the beginning, we put a lot of it here.
Right.
And then you realize your controllers start to get really unwieldy. So you're like, oh, well, we probably shouldn't put them here. So then we start to migrate the business logic over into the model. But now your model's serving two responsibilities. It's modeling business actions, but then it's also mapping data to your persistence store.
Yeah, I'm sorry to slow you down.
No, no,
Okay,
it's
so,
fine.
so you're saying you're putting business logic in the model. And I'm having a hard time grasping that. You know, like I think of like a model, sort of, you know, it's abstracted away as an object, right?
Mhm.
So you basically have methods that you say, you know, find so and so.
Right.
Right.
Mhm.
So how are you attaching business logic to that abstracted model?
Therein lies the problem. That is the core problem, is that the way most MVC applications are built, the business logic is conflated between the controller and the model, and so it's usually weakly defined in both. It's all implicit, and so it becomes very, very hard to test.
So you're saying that the solution was for you guys to shut business logic over to the model, the code for that.
So right in between here is your application.
Okay.
Basically, your application lives here, and your model then becomes persistence on. Your model is basically just your persistence mechanism, and so here the controller translates commands or queries to your application, and then depending on whatever your application needs, it then updates or pulls data from your database as needed. So that was the big thing for us, is recognizing that we were violating SRP in a myriad of ways, and because this was the pain
actual
point.
pain point was controller methods or functions on the controller that were hundreds of lines,
Yeah.
hundreds and hundreds of lines of basically procedural code.
So you're gonna show us an example?
And this is why we couldn't write tests,
Okay.
because those tests are so unbelievably painful to write that you don't write them. You cannot write them. And so we're going to get started with basic intro to TD and how we do it with PHP, or how we did it with PHPSpec. And so what we'll do here is we'll start with the composer.json. And if you've used use Composer. If you're not using Composer, use it to manage your dependencies. And PSR for autoloading is amazing. It is the way to organize your files and your projects in PHP. In fact, I love Ruby, but Ruby's autoloading is not as good as PHP's. I think this is the one thing that PHP has hands down over Ruby, without question. So all we set up is we have PHPSpec is going to be our testing framework that we use. You can also use PHP Unit. I like PHPSpec because of it forces some certain paradigms on you that writing poor software becomes very painful. And so if it gets hard to do, if it gets hard to write those tests, that's a good indication that you're probably not organizing your classes correctly. So we have PHPSpec, and so we've already run PHP Composer install. I think that's already set up. Yep. So I can do PHP vendor bin PHPSpec, which is when you run Composer install, that the binaries that are there will exist. I'm gonna alias this so I don't have to type this out each time. So just alias PHPSpec PHP vendor bin PHPSpec, and let's make sure that works. Yep. Okay. So these available commands are, the big ones we're going to focus on are run and describe. So the first thing we'll do is we will remove all the existing tests. PHPSpec run. Okay, so we have a clean slate. We don't have anything written yet. So the test-driven development methodology and workflow is red, green, refactor. So with red, green, refactor, you first before you write any production code, you must first write a failing test, and not compile. And from how Bob Martin has defined it, not compiling is a sufficient failure. For us, what that means is most likely you don't have a class or method defined. So the first thing we'll do is, and the namespace I'm going to be using for this project is TDD, all caps. So I do PHPSpec describe TDD note because it's bash, it's / instead of back, but that gets translated. And we'll start with Fibonacci. Fibonacci. I hope I spelled that right. Did I spell it right?
I think so.
Okay.
I think there's 3 C's.
Stop it, Ryan. You stop that right now.
I know the X is silent.
Right. So it's
What was your alias on PHPSpec again?
overwrite. Yes, we will overwrite that. So I think it's which PHPSpec. So it's alias to PHP vendor bin PHPSpec, and so that'll only work within my current working directory. So when I ran the PHP describe this, it creates it in my local directory. So now if I pull up my spec, you'll see that it's built this file for me. And this is automatically generated for you when you run your describe. And so it puts it in the appropriate namespace for you. It brings in the correct aliases for your testing objects, and then it creates a spec. Now, the first thing that it does is it creates this test saying it is initializable, and this should have type, the type that you specify. Now, this is one thing that it can be a little confusing about PHPSpec that I wish was more explicit, but I understand why they did it. So whenever you see this, it refers to two things. In the classic PHP sense, it refers to the instantiated object Fibonacci spec. But it can also refer to, but most often it will also refer to the object under test. So when you're looking at this and you're asking testing questions about it, it's referring to a class with the namespace TDD Fibonacci. And so let's see what that looks like. So I have a test written. Let's see if this fails. PHPSpec run. TDD class TDD Fibonacci does not exist. It's a broken example. Now, this is one of the really helpful things about PHPSpec. It helps me out. Do you want me to create this class for you? Yes. So this is compiling is also failing. Well, we don't have the class. Same thing. So I say yes. It reruns it. It reruns the tests for me, and we see that test now passes. And so if I look over here in the source directory, source TDD Fibonacci, I now have the class that I'm testing. So what we'll do is we'll keep Fibonacci simple, and we'll do it by just the definition of Fibonacci to begin with. So function. So let's just start writing some tests. It returns 0, 0 for the Fibonacci of 0. So then we do this, Fibonacci 0 should return, nothing like live coding, man.
Yeah.
Should return 0.
No pressure.
That's right. And I'm going to write Ruby sometimes in here. So just when you see it and I miss semicolons, just, hey, you missed a semicolon. It's gonna happen. So I run this test. It says, do you want me to create the method Fibonacci for you? Yes, I do. So now it reruns a test for me, and I see it returns 0 for the Fibonacci of 0, expected the integer 0 but got null. Well, that makes sense because it's created this function for me, but there's nothing going in here. So the next, since I failed, so the next part of the philosophy is you write the minimum amount of code required to make it pass. So I don't write the algorithm for Fibonacci. All that's required is for me to return 0. So I'm going to do that. Return
It seems
0.
strange.
And it's about slow iterations and not letting your code get ahead of your tests. So I run this and it passes. So the next part of the definition. So where I'm getting all this, so Fibonacci. So just from the definition, f of 0 is 0, f of 1 is 1, and then the function, the rest of the function. So these are your initialization variables or values, and this is the definition of Fibonacci. Now, and I'll show you how we end up to that. So we go back to our test. So the next step would be function. It returns 1 for the Fibonacci of So now we write the test, we run it. Is this big enough for y'all to see? Okay. So I expect it to return 1. When I pass in 1, I get 0 instead. That makes sense. So now the next most simplest thing to do is if argument, and I'm just going to change that to n. If n is equal to 0, return 0. Return 1. And this passes. Still not Fibonacci, but
Right.
we're iterating closer to it. So the next step is to drive closer to that example is function. It returns I think it's 13. 13 is not guess. 0, 1, 2, 3, 4, 5, 6, 7. Okay, 13. Returns 13 for the Fibonacci of 1. So then we
Of one
Maybe 7.
or 7.
you are correct. R7. R7. 13. Got that backwards. Fibonacci 7, F7, 13. So I run the test. As expected, it fails.
Right.
So now's the best. Now, TDD in algorithms is kind of contrived because we already know what the algorithm is for Fibonacci. But we'll see in the next iteration of the hello world that we'll do where TDD can become very useful. There's not much refactoring we're going to be able to do here, but we do know that now we want an else if n is equal to 1, else return, and now we can just use the definition of it. So this Fibonacci n minus 1 plus this Fibonacci n minus 2. And that passes. So the important thing about testing is to keep your tests few in number. Have every path tested, but don't do duplicate testing if it's not needed, because you tend to bind yourself into implementations that are unnecessary. So function it returns 144 for the Fibonacci of 12, 5, F7, 12, F3, X44. So I've created this extra test that's already passing from the beginning. It's not really telling me anything useful, and it probably should be omitted. Now, if in the future you find yourself having, if a bug crops up, that means there's some element of this program that you've misunderstood, and the fundamental algorithm is incorrect. But until we find an occasion where that's incorrect, we probably shouldn't do it. So it'd be more appropriate to get rid of it. So now we're going to do everyone's favorite classic hello world. So before I do that, I'm going to use one of Sandy Metz's slides. She gave this presentation at a conference in Portland back in 2013, I think. And hers was the magic tricks of testing, and all this is coming from her. She's the source material for this stuff, and she's a very good explainer. So when you're looking at an object, there are 3 types of messages, and it's important to think about object-oriented programming as just passing messages to an object, just giving something to an object. Now there's three kinds of messages that an object is concerned with. Messages it receives, so incoming messages, messages that it sends to other objects, that an object sends to another object, and then messages that it sends to itself, so protected or private methods. These are the only three things you need to concern yourself. These are the only three types of messages that you have to worry about when thinking about objects. So then we go to her slide about the things that you want to test. I have a slide that has good attribution. So when it comes to incoming messages, when you're doing queries, so calculations are a great example of queries. Fibonacci. This was absolutely a query. Commands, we haven't done a command yet, but you make assertions on the direct public side effects. We'll do an example of this, but this is setting a value and then having something that returns the result of that value, setters and getters. Try to avoid these when you can. They tend to be they tend to tell you things that are redundant and not always helpful. Messages sent to self are only going to be hiding. These hide complexity about what's going on in the queries and commands. So if you have a test about a query or a command and messages are sent to itself, these are implicitly tested, and so you don't need to test them. Outgoing queries, this is when you're talking about mocks and mocking other objects. And we'll do an example of these. You don't really test them, you just mock them. And if you write tests to ensure your interface is clean and uniform between mocks and the implementation, you don't end up with that API drift where you have a test suite that runs and says everything passes and your app is broken. We've all done that, and this is typically where you get into trouble when you mock things in a way that you don't guarantee consistency between the API and the object that you're mocking. And then expect to send is any object that so an object that another object sends. You just want to guarantee that it sends that message. You don't care. It's not this class's responsibility to know what that object does. It's that class's responsibility. And I'm using too many different pronouns that are all sounding the same. So we'll look at this one a little bit more closely in a little bit.
So looking at that graph real quick, where's the one to focus on most, would you say? Like 20% gives you 80% results. Is that the expect to send, or is that the
queries and expect to send?
Right there.
These two will give you the most bang for your buck. And what Sandy Metz will tell you is break all these rules when you know them, and it will save you money. Because testing is really about being able to sleep at night and saving yourself money, saving you and your clients money. That's what this is about. So let's go and let's do the greeter. So PHPSpec describe greeter. TDD greeter. I run it. Yes, create it for me. And so now I have a new greeter class and a greeter spec. So the first thing I want to do is let's just create a hello world method. Function So I run this test. I don't have the method yet. Yes, create it for me. It runs it. It creates the method. The greeter creates the method, and obviously it breaks. So the most simple thing to do is to return hello world. That is the most simple thing we can do to make it pass. So now let's close the other ones we don't need. And it said it greets individuals. This hello Ryan should return hello Ryan. Yes. So the simplest thing to do is return hello Ryan. And that passes. Now, a test passes, but that's not really doing what we want. Objectively, we can see that what we want this method to do, it's not going to do. So let's create another expectation. And we run that, and now we see that our initial thing that we wrote is not going to work. So obviously what we're going to do here now is interpolation. So I run it, and now it passes. So it says hello world, it greets individuals, and we have a class that works. Now comes the refactor part. And the refactoring on this, because it is a simple method, it's really not going to be an improvement. But I want to see how you can make certain generalizations that you're now confident to try and experiment with now that you have tests behind it. We've done this whole thing in a test-driven manner, so we can make changes to it and know that if we get our tests passing again, that the code will have changed, but the result of what we need, or the result of the API, is still the same. So we see here that really these are the same thing. And so what I want to do is I want to change how hello world works inside. And I say I want to return this hello world. Our tests still pass, and we've recognized that we've seen this generalization. We've found a generalization about the code that we can make. Now, here, what we're doing right here, is a message sent to itself. Now, it's not a private method, but it is sent to itself, and we don't need to test that because we are already asserting, we already have it implicitly tested through the query. Tests here are redundant and unuseful, and if you have this expectation, say, yes, I send a message internally to hello, you're now binding your tests to the implementation, and your tests should make assertions about the interface, not the implementation. The implementation should be able to change however you want it to, and your API should be able to remain constant. So now let's add something new to it. Function it greets generally. So this hello should return hello. So we've got a failure here. And part of the failure is that it's expecting an argument, but we're not passing one in. So back to the TDD, red, green refactor, you write a test that fails, and you do the minimum amount of work to make that test pass. So the minimum amount to make this failure go away is probably this, where we provide a default value for name. We'll just use it as an empty string. So that error is gone, but now we have a new error, or a new failed assertion. So now we need to make this, we need to fix this. And we can do this a couple of ways. We could do if Sterling, is it Sterlength?
Oh,
No,
Pardon.
nice.
There you go. Thanks. Name is greater than 0. Else return hello. So that works. We could also return this with I did this last night. What did I do? String, I think it's a string replace. Replace. So space, and we're going to replace that with an exclamation point, and the subject being the name. Got world. I had the same error. What am I doing wrong? Ah, okay. So hello. And this is how tests save you, where if you make an error, it should tell you. Your test should be descriptive enough to tell you what's wrong. Hello world. I'm doing note for note what I did last night. It's great.
You made yourself a little content.
That's right. And so now we've made this generalization of recognizing this is probably what's going on. Well, I don't really like putting this in the hello, so let's just change how this works. Function compress greeting. Return. So I'm actually going to do this here. Greeting. Now return this compress greeting. I'm being too hard. Don't bother. I run my tests, they still pass. Granted, this is contrived, and I understand that. But you can see how you can change the organization and layout of your classes. And if your tests are strong enough, you can have the confidence to change the implementation when you realize that there are better ways to organize it. And you can go to sleep at night. So now what we've done is we've done assertions on queries. We've shown how you can do messages sent to self and how we can still ignore them and still be confident about the result. So what I'll do now is the next thing that we'll do is we'll have a person, and then we'll have that person change their name. So let's close these. PHPSpec describe TDD person. PHPSpec run. Yes, create that class for me. So now I have this person and this person's spec. Now, all I want to do is function it sets a name. This set name. This get name should return. So I call the command, and then I make an expectation or an assertion about the direct public side effect. So I ask, do you want me to create set name for you? Yes, I do. Do you want me to create get name? Yes, I do. Now it doesn't work. So so we create our implementation. This name equals name. Turn. Okay. So here we've now done the implementation of a message sent to the person object that's telling it to do something, change your worldview, and then you get and then you test about a direct side effect that relates to this. Now you don't always have that available to you, and sometimes there aren't direct side effects. So if they're not, don't worry about them too much. And if they are, if you don't have a way to test it, it's either you don't have side effects or you have outgoing messages. If you don't have either, I'm not sure why your method exists. So now we've hit these guys, and we'll probably skip this for the sake of time. We'll do this expect to send. So let's have an observer. Let's have a person observer that we're going to inject into the person class, and whenever the set name changes, we're going to make an expectation that that message is sent. So we're going to write the, you can do this a couple of ways. I would prefer to write the observer first. And so I'll do PHPSpec describe TDD person observer. PHPSpec run, create it for me, yes. And okay, so I'll go ahead and do it this way. So let's go out of order. So here, now we do function, it notifies observer upon name change. Now we're getting into the area of spies or mocks where you can expect things to receive messages. So PHPSpec does this in kind of an interesting way, and you have dependency injection handled in a couple of ways with PHPSpec. So the first thing we're going to do is this set name Joe, and the first thing we're going to do is we're going to type hint person observer and there we go, observer, and we'll do observer, what is it, name changed to Joe should have been called. See if I'm remembering that correctly. So collaborator doesn't exist. Spec person observer. So I'm writing the code that I want. Well, this guy doesn't exist. And actually, okay, so this is actually a namespace issue. So it's, we'll do it up here. I prefer to do it up here. Use TDD person observer. Okay, so now it's telling us, hey, this observer that you might, and this is one of those things where keeping your APIs in sync is important. PHPSpec helps you do this. So now we go to PHP observer and we just define how we want it to behave. So function, it has, what did I call it? Name change to And I'm going to speed this up a little bit for the sake of time and not worry about anything that it does, just make sure it has that method, Joe. So I run that test. Yes, create it for me. Okay, good. So what happened there, if we back up, it said, hey, you don't have this method on the person observer. So I went and wrote a test on the person observer that basically just called this method. And I don't really care what this method does right now. This is going to, when we work about the person observer, we'll worry about its implementation. But right now I'm focused on person and just saying, hey, make sure you pass that message in. When we do this and it creates that method for you on the person observer, it creates it for us. This is now satisfied. This observer now exists, and now this expectation that, hey, this should have been called, that now appropriately fails because it hasn't been. Now we're getting into dependency injection. So you could say, to get something working quickly, you could just create an object. So all right, you're gonna help me, right? Person, new, no,
What do you call it?
new person. There we go.
There you go.
Person observer. We could do it this way. Observer, and then observer name changed to. We could do it that way, but we shouldn't. Because anytime you see another class's name within a class, it's a dependency. And you need to inject your dependencies. And if you don't inject your dependencies, it becomes nearly impossible to test things in isolation. And if you don't test things in isolation, you no longer have unit testing, you have integration testing, and then you have Rails. And Rails is great at a lot of things. And in fact, I think Rails' lasting legacy is going to be bringing test-driven development to web applications, but they are not known for fast tests, and it's because almost every test, every expectation hits the database in some way, and that's just slow. So we need to inject this somehow. So I'm going to get rid of this. So in test frameworks like PHP unit, you typically have like setup and tear down or things like that. In PHPSpec, they call them let. So that is the wrong class. Actually, I don't need observer anymore. So function let and it creates we pass in, and so PHPSpec also basically kind of does dependency injection at the method level as well. And so this is how this is working behind. This is using reflection to generate all this stuff for us. So if you think about it, if you just read this, so let this be constructed with observer. So if you just think about what you want to do in English, your setups are going to be easier. So let this be constructed with an observer object. I run that. Do you want me to create it for you? Well, sure. Still fails. That's okay. So now we have our construction. Let's go ahead. Observer. This observer equals observer. Create observer. Whoops. 17K. And now our tests pass. And so now we've gotten that last corner where the responsibility of whatever that observer does, the person observer is responsible for its behavior, not the person. We don't care what that person observer does. That could be some sort of reporting system. That could be emails, that it could be dozens of observers that each have their own responsibility. The person shouldn't care about those responsibilities. Instead, it just needs to be responsible for saying, hey, I sent this message to this person. It's up to them whatever they do with it. And so that is basically unit testing in a nutshell with PHPSpec. And I think the benefit of doing it this way is it forces you to have smaller classes and more cohesive and fast tests. And I think people tend to be shy about creating more classes for things. I'm a big proponent of having something be explicit behind a class and a method rather than have it be an implicit in some sort of procedure that you have to kind of tease out and understand. You have to read through a couple times to understand where a name would really help along the way. There's two hard problems in computer science. Naming things, cache invalidation, and off by one errors. And I really think that naming is the thing that is hardest to do. And if you have a good name, it very easily tells you what's going on and what the purpose of that class is.
There's some problem with where to eat lunch.
That's
the hardest one for me.
that's a daily battle. So what questions do y'all have?
I think for us, it's hard to that paradigm of testing first, writing your tests to
Right.
fail, then writing the code. I mean, it sounds like a great concept, but implementation is always kind of hard. It's hard.
It took
hard
me-
for to grasp.
It took me 2 or 3 projects of trying and failing to finally get into a flow that I was comfortable with. And really, it took me understanding what I was doing. And the testing tools that you use are very, very important. PHP unit is kind of cumbersome to use, to be honest. It can be. And a good example of, or what I said earlier, a good indication that you're organizing your code incorrectly is if your tests are hard to write. And if it's hard to test things, it probably means your object under test is trying to do too many things and doesn't really know what it is. Or there's some other complicating factor that you haven't quite yet understood and pulled out into its own concrete class. It's fortunately for me, but unfortunately for you, I've got the benefit of spending a lot of time just reading about testing, watching more videos than I probably have any right to about testing, how other people do their testing, and seeing that flow over and over again in different ways, and seeing the different hangups people have. And it did take me 2 or 3 projects to finally understand what I was trying to do in testing. Another part of this is I'm doing unit testing right now. I am testing these objects in isolation, just focusing on what an individual object is responsible for and nothing else. Then you have the set of, and the naming is really convoluted and you don't really know where the line is easily defined. So then you have like integration testing, where you're testing your application from HTTP command or query to the result where it hits the entire stack. That's a whole nother type of testing that is much, much slower, but then gives you a better view of what your application is doing, and if you've hooked all these individual components up correctly. Unit testing is great for saying, under isolation, I know what this object is supposed to do, but you can still put your objects together incorrectly. And this is actually something that dynamic languages are not as good about. You can put different classes or different objects together incorrectly, where with static languages that I've found, you're more protected against that, because a part of the definition of methods and classes, that the types protect you from making those mistakes, where you have to be much more explicit about that and more careful about that in your tests and your setup.
And another question. So you have this, let's say you built this suite of tests because you've had this application for a while. And this application is based on business rules that have been handed out to you. And all of a sudden they go, all right, we're changing the business rules. Fibonacci is no longer, n minus 1. It's now n plus 1 plus, square root of 7.
I'm fine.
So you have to change all your tests. How do you decide, which ones to keep, how to add new ones, and which tests to discard?
So that's a good point. You need to be willing to delete your tests, and I think one of the big moments for me in understanding about software development is we always get irritated with the customer when they change their mind, right? Why did you change your mind? This was working great. There was no problems here, and then you decided, well, I don't want it to report this, I want it to report that, or our business model has changed, so we needed to do this way. And object-oriented design is about building applications where they are easy to change. And when you make the changes, you're not spending a lot of effort in doing so. When you need to make a small change over here, and you have to rewrite your application to do it, you have a complexity problem. And not a complexity, a complecting problem that, what's his name?
Hickey.
Rich Hickey, yeah. Where you have too many things that know about too many other things. And the design, you probably don't have enough tests to keep you from doing that. Because if you did, you would not have done that, because it would have been too hard to write those tests. But when the business rules change, as they do, you need to be able to respond with that. And well, if the business rules change, the tests have to change. And you may need to delete an object or delete class definitions and test definitions that no longer satisfy. That's one thing that I've been pretty adamant that my team gets irritated with at times. But if they decide to rename some concept, I go through and I rename it in the class, or rename it through the project. Excuse me, because you don't want to have to translate between some business concept and some technical concept. And the more translations you have, the more you bind yourself to that project, where you can't ever leave that project because you're the subject matter expert on it, and nobody else knows the application because you built an application that has to have a translator between the business person and the developer. And this goes back to the idea of a ubiquitous language. It comes from domain-driven design with Eric Evans, where you have a consistent naming. If the business people use a specific name or phrase, you should see that name or phrase in the code. There are certain things that don't translate one for one, but when you say if you say member, I probably shouldn't have the user. I shouldn't have a user. They should be if they're both members. If you're using user, the name of the class should be user. And if for business reasons those things need to change, go ahead and make that conversion and translate them over. Sometimes that takes a long time, but you're reducing the mental overhead of keeping track of this mapping.
Richard, sounds familiar?
Yeah. And you're saying it's worthwhile to go back and do the translation?
It can take a lot of time. But
Makes the code understandable.
it makes your code more understandable, and it makes onboarding of new developers easier, because then the developers, the idea that you have to have someone translate a business concepts and have a middleman to explain things to the developer, because the developer just doesn't understand this business idea. If the developer is not intellectually strong enough to understand the business they're trying to model, they have no business modeling it. And if that's the case, if you find yourself in that position, you get rid of that translation step, because then when you try to onboard new people, not only do you have to teach that person how the business works, because they got to understand how the business works anyways. There's no way around that. They have to understand how the business works, but then you have to have them also learn how to translate this business concept into the application concept. So you're creating more work for yourself as a developer, and as a leading developer onboarding new team members, creating more work for yourself again, and for the new people you try to onboard.
Don't forget that when the client says member, they mean user.
Mhm.
And your UI says user, and your controllers and your models say, or your UI says member, and your backend says.
And this is very much an iterative process. We all know the clients don't know what they want, and you have to tease it out of them and figure and work with them and have a lot of conversations and a lot of dialogue between the developers and the client to come to this ubiquitous language. And they should exist in your tests. You should see the same business ideas reflected in your tests. And if a business rule or concept changes, change it in the tests, and then have that change reflect over to your application. And so going back to earlier about MVC and the application and how we complex things too often. Really what we did, we extended the object-oriented design principles of individual objects. We expanded that to the application as a whole. And this comes from like the hexagonal architecture, where you have units that you can plug into your application, and you're not bound by any one implementation. You can change databases easily if you need to. We all like that. Oh, well, you use an ORM so you can change a database later. Nobody ever changes their database, because all your business logic is tied to that ORM that business is supposed to be, or that business logic is supposed to be modeling. And that's the mistake we make, is putting too much, giving too few objects too much responsibility. And if you have testing in place, you're gonna find the places where it's painful to do so. One thing I will.
Stupid question.
Sure.
It seems like you're doing test-driven development, so it's almost like you're trying to tickle yourself when you know what the outcome's going to be.
Mm-hmm.
So, what is there ever, like, you hear about team programming and stuff like that?
Mm-hmm.
Is there ever a situation where it makes sense to have somebody write the test?
That is
somebody else.
That is, I know of shops that do that. I think it would be really hard to do with communication, because it's a fast. It's supposed to be fast. You write the failing test, you run the test, then you write the implementation that passes that test. You should be doing that several times a minute.
Yeah, it's an iterative.
It's a quick, small, iterative process. And I think, I've ran these 13 examples, and this is one thing that I really like about PHPSpec is it's fast. It's very, very fast. Ruby can't say that.
But what about like an integration test that makes sense to do something?
Integration tests, that probably makes a little bit more sense to do. But if you're going to do that, I would say have someone side by side doing that kind of pair programming. If you're having, hey, would you write that test for me? And then 15 minutes later, the person that's supposed to implement it does it. And then we find out, well, the test is not quite complete enough. Hey, could you get to the next part? That's introducing a lot of process that would be very cumbersome to overcome, I think.
You talked about when you're doing maintenance, and then you're having to maybe discard some tests. I've just read about some people who test that sometimes they discard a test that they shouldn't have, and they bit them later on.
That's
Is
where your
there-
change management.
How do you make that decision on what test to discard?
I mean, hindsight's 20/20.
Yeah.
When you're deleting tests, you're fine deleting tests so long as the code that it's supposed to be using is also gone. Don't delete a test if the production code is also gone. Don't delete a test if the production code is still there. So if we go back to the person spec and observer, this is a good example. Let's say, okay, I don't need to worry about notifiers anymore. Let's just say we're not worried about it. So I delete this test and I run examples. My tests still pass, but now there's code that exists that's untested that maybe we want to run, maybe we don't want to run, but we don't have any guarantees about what it's doing or that this code is being executed. And so if you need, think less about deleting tests and think more about deleting functionality. And you delete the implementation functionality first, and then you delete the test. So let's get rid of that. And then we get rid of this. And then we have more guarantee there. Redundant tests, on the other hand, are, I feel, safe to delete. So if we go to the Fibonacci and the Fibonacci spec, which actually I already deleted, where I did Fibonacci of 12 should return 144, that's redundant and doesn't really tell us anything more, and it's okay for us to delete that. But if you delete a test that captures a business concept that is now implicit instead of explicitly being used, you've deleted too much. So delete explicit redundancy, not implicit redundancy. So a good way to do that is see, where did I do that in this one? Okay, so if we look at the greeter spec, so I did it this way, but when I did it this way, I was allowed to give myself enough room to get myself into trouble by hard coding it in. So I had to have some idea of interpolation. When I pass in an object, so Ryan, this is where you can get yourself into trouble, and I probably wouldn't recommend this, because then your test matches your undefined variable Ryan. Right, of course. Is okay. So I'm jumping ahead. You tend to see this in Ruby a lot more, where your test, setting up your test looks exactly like your implementation, and in which case there's not a whole lot of value there. Try to organize your tests in a way where it's not immediately obvious how it's being executed. That's really hard to do when you're working with strings and things like interpolation. It's very obvious what you need to do here. And so this is not necessarily a complete example, but if you think more on terms of passing objects messages, and it's less about like pulling strings around and objects passing other objects around to other objects, this becomes a whole lot easier, and you get you get to avoid tests like this where you have to have redundancy built in to protect yourself against language constructs. Did that help explain?
So have you been able to tickle yourself? Is that, because I think that's a valid concern. I've heard that quite a bit.
Testing should be, it should not be painful. It shouldn't feel painful. And it should be, there will be a moment in the beginning you'll feel that this is dumb, it has no value, it's slowing me down. And in the beginning it will slow you down because you don't know how to write tests. You don't know how to use
How to write testable code for that.
you don't know how to write testable code. You don't know how to write tests. You don't know the testing framework you're using to write tests. And so in the beginning you will be slower. There's no way to get around that. But you'll get to this moment when you'll push something up and try to deploy it, and hopefully with testing now, you'll have some sort of continuous integration set up, and the CI will run your tests, and it'll catch something that you had missed, and you'll avoid a deployment with a bug because of the tests you wrote. And you'll have that moment, and you'll get to the point where, okay, I now see the value of tests. I'm glad I have them written. But until that point, you're going to be frustrated, and you're going to see them as a waste of time until you realize that you're now no longer up at 1 a.m. fixing something. And that's actually why I got so aggressive about learning how to test and write testable code, particularly with this PHP project, was that it was a weekly occurrence, and sometimes several times a week, where I would get calls late at night or early in the morning because something was wrong with the server, and I was sick of it. And we did it to ourselves. You know, you can't point the finger and say, "Hey, you did this." No, I wrote the code, and there was something wrong with it. And because we didn't have this, and oftentimes it was not that an individual implementation was wrong and didn't make sense. It was the fact that some change here broke something unrelated over here, and we had no way of knowing. I sleep better now.
How do you prioritize? I mean, like you probably have a checklist of things that you want to test for. But how do you prioritize what order you're going to put it in? Do you prioritize by like what is the most important function? What is the most common? How do you do that?
I think it's the same way that you do any just regular application development, where you just break it down into components. You know the individual components you're going to need, and so you just start building the components piece by piece, and try and focus on modeling the domain and building the features that you're wanting, and just build it feature by feature. And
and this it jumps out to me that we probably want to, the hello world, we probably want to test strings first before tossing some object or an array or null, or null and the strings matter first, rather than anything else. So in that contrived example, it invites us to test its first case. I guess I'd say the happy path first, and then the path we're most worried about breaking.
And I'm also assuming that, let's say, you have the huge test suite, and all of a sudden something breaks because of something you never thought of, and it was like a user's unintended use. Like you never knew that they would do that. Right. And you would then incorporate that case into your tests?
Yeah, absolutely. And I mean that's one thing is you're never it's impossible to, I mean, it's not impossible to write bug-free software, but no one's ever going to do it. And it's also the fact that, we're only able to understand so much. And a bug means that there's some element of complexity, that the problem was too complex to understand, and there was some element of it that you just didn't have a thorough enough understanding about. And, I mean, users are great for, helping you find those things you thought you understood and don't really get. and that's where the tests, when you find a bug, typically, I haven't done it this way before, but I have seen, or I do know of people that will write a test expecting the bug to exist, to make sure that they understand. They write a test to make sure that the bug occurs. Then they write a test that should fix. So they write they write a passing test to make sure that that bug works the way they thought and called like they thought. Then they write a failing test that should fix that bug. Then they write the implementation that fixes that bug that then fails the bug test, and then they delete the bug test.
So it's kind of like duplicating the error, but in an automated way first.
Right. And I think the most important thing about your tests is to keep them fast. If they get slow, you're not going to run them. If every time you run your tests, it takes you, 4 or 5 minutes to run the suite, you're not going to want to do it.
What's a typical runtime for tests?
Let's see here. I would know how to do this in Ruby.
I usually found that varies with what's automated, or especially if I'm using Composer and has a bunch of verbose classes, But I found that's usually contribute to how big the code base is, or the complexity of the classes and how they play together. Dependencies, like you were saying, all of that plays into the runtime of the test. But traditionally, they're pretty fast.
I mean, with unit tests, they should be fast. They should be tested in isolation. You should not be hitting the network. You should not be hitting databases. You should be hitting the file system.
Files, yeah.
These should live entirely in memory. And I've been trying to keep my integration tests to where, just to guarantee that I've got things hooked up correctly and not worry about all the different paths they can take. And it's about time and efficiency and cost. And you can write integration tests and acceptance tests until you're blue in the face. You'll never get all the edge cases, and the test suite will become very, very, very slow. And so the bulk of testing should be done at the unit level.
It is fragile and painful to run like an automated browser and try and run it end to end compared to this.
What if you had to do it?
If you got to do it, you got to do it. But
Then,
it takes a lot of time.
yeah, I've had browser automation tests that take 20 minutes to run a suite to prove one use case. It was not optimal.
But it was a fairly complex application, right?
Yeah.
As far as
Yeah.
screens, views.
A lot of-
Absolutely.
A lot of state change,
But if you're in
getting the DB, yeah.
Right, but if you're in a spot where you have code that's not really feasible to unit test or it's cumbersome or expensive,
Right.
you have to fall back on end-to-end testing or functional testing.
Yeah.
That's something you gotta do, especially if it's a complex app. I mean, you can't get around writing those.
Yeah.
And a lot of those tests are gonna be verbose, because you gotta, grab the DOM, wait for it to initialize, change page and such. But once you get it down to a science, it's second nature. Like I said in the beginning, it's gonna be very cumbersome, very frustrating, but
Selenium WebDriver is a good one.
yeah.
It'll automate. It'll either record a macro basically and play it back.
No, I've toyed around with that. Now, I heard that there's ways to import that as a script, right?
And run a headless browser. Yeah,
Yeah.
Fabric.js. I've had some fragility with those, where and I think it has to do with how the elements of the DOM are loading. But the test would fail on a selector not being there. While I'm looking at it in the console, that ID is right there, that XPath is right there. So they're a little more fragile. Yeah, a lot more fragile.
You're saying your regular browser's more fragile.
What's that?
You're saying that if you run your test with a regular browser, it's more fragile?
More fragile than unit tests.
I found that actually headless browsers are really more fragile than actually.
Yeah.
Yeah, because I'm looking at it in the browser,
Yeah,
it's
exactly.
fine, but Phantom.js, and there's a web driver for Selenium I was using on the same project, and my assertions would say, I can see this element in the DOM, and it would fail. I'm sitting there looking at it in the real browser, it's right there.
Is that like a
And-
response time issue or?
In XPath selectors, DOMs,
It was,
code.
Who knows?
Who knows? It just has never been. And that's where there's a good library called Mink. Mink tries to bridge the gap between headless browsing and actually using an actual live web browser driver. And so I don't really. I think Mink's part of the hat suite now, if I'm not mistaken.
yeah.
I think you're right.
Yeah, but Mink's really good. But yeah, it just depends on the code, how the CSS, what type of jQuery we're using. Because you could have like the most recent version of jQuery, roll it back to a different version, and it'll break the whole test. I've seen that happen too. So it's very fragile. It is very fragile.
And the tendency, the UI tends to change the most quickly out of any part of the application. Okay, we need to change the DOM structure here so we can support a certain kind of style, or for whatever reason you need to change the DOM. That changes so often that you then find yourself where these other tests are now out of date, and then you go to update them, and it takes a long time to run them. When, okay, I just needed to change this, instead of a UL, I needed an OL, and now I've got to wait 10 minutes to make sure that I've tested the right thing. That's slow. And so one of the things, if you want to help mitigate some of that, is do as little logic in your views as you possibly can. One of the big things that I have tried to start doing is you have just plain old DTO, data transfer objects, DTOs, that you construct with whatever business logic you need. It doesn't matter. I mean, you have to do for eaches on stuff, and you have to have conditionals on what displays when. You have that tested logic, because view logic is business logic. We try to pretend that it's not, but I want something to look a certain way, or I want to render a certain amount of information a certain way. That's business logic. So test how that stuff is constructing your DTO, and then just pass this dumb object that's just nothing but a collection of getters to your view layer, and you then get to cut down on a ton of testing that you have to do, and you're not worried about. I mean, we've all had unable to call method on nil object or null object. I mean, every language has it, and you almost always see them in views, and it's because we expect our views to do too much, and it's very, very painful to test views. So if it's that painful, let's stop doing it and test it further up. And this just goes back to how you're architecting the entire application and extending object-oriented design principles to more than just your model and leave it at that. Have everything tested to include at your views, and then just let your view be a dumb representation of whatever you need it to be.
But if you have a reporting application and it's all about the views,
Mhm.
and then so when you're doing computations and you change something, I mean you're really, I mean you need to go. Your tests have to look for a certain div. This div has to have a certain value.
Right.
And that's the struggle. I kind of see when we're looking at like certain applications, like reporting applications, or something that's a very view intensive. It's about a lot of user input and a lot of user interaction. That seems the most complicated.
Yeah, it definitely can be, and I think where we get astray, especially on reporting applications, is I mean this goes back to the separation of content style and behavior that we've got in front end development. we still tend to conflate those in our applications where you have markup for the sake of being able to structure your style, or for the sake of being able to provide structure for your styles that are important for the presentation of something, but the content doesn't really apply. What's important, the business part that's important there might be the content, and we don't have tests on that because we have this extra cruft there to support the styling, and it gets hard. And so that's why I support the idea of having a demarcation between the data transfer object that represents the report. And you can take that report, and when you pass over this view layer, you can send that to HTML, you can send that to XML, you can send that to JSON or whatever you need, and you do that translation here, and the DTO that you expect is fully tested. Then you can have this interface of translation tested, but you don't have to worry quite so much with the logic that happens over here, because there shouldn't be any, because it's nigh impossible to test with any confidence.
One last question. I'm sorry.
I I love talking about this, so no worries for me.
Are there like return on investment numbers on on test-driven development where somebody has quantified, okay, you spend this much time in test-driven development, it'll only save you this much time in actual user testing and program costs.
My experience is going to be anecdotal, not quantitative.
It's hindsight driven too.
Does anybody see anything quantitative? I think that's the essential question, actually.
It's something that the developers that adopt it and believe in it can confidently say, yes, this helps and it makes you faster, but it's not something that I think that there was a I don't even remember the name of the talk now, but basically a man did a 6 days in a row. He wrote an implementation to convert, I think it was just like regular Arabic numerals to Roman numerals. Build that translation to Roman numerals or vice versa, something like that. And he knew the algorithm, and he did it 6 days in a row, where he did the same practice. And one day he would do it without tests behind it, so he just pull up his terminal, run it. Do I get the right output? Yes, no, and then keep doing the implementation. And then the other day he would alternate with writing it in a test-driven manner, and for each time he got faster each day, but his TDD, his test-driven development times, were faster each moment. I wish I could tell you who that was, but I mean that's one, I guess, one empirical anecdote. But I think the curve, when it comes to object-oriented design applied to the application as a whole, especially when it's guided by tests, you're looking at, and I think this is the Rails curve as well, or just, not even the Rails curve, just the MVC curve, where you have this quick ramp-up time when you just shove everything in the conventional place without tests. You have this quick ramp-up time where you can have a lot of neat deliverables to the client. And then it begins to taper off because you've got so much complexion and debt that you can't, it's very hard to make incremental changes. Whereas the other line is more linear, and eventually those points will cross, and you'll always be going faster when you're guided by tests than you are when you're not guided by tests. And finding out is the trick for you is to find out where that point is on that line. And for me, when you're talking about just doing something in a test-driven manner, you're on the order of weeks, maybe a month or two if you're under active development. So you get quick returns for, and there's something to be said for not having bugs crop up all the time. You have them, if you write tests correctly, you have fewer bugs.
I was kind of thinking maybe it was like less QA hours, you know, because if you have a quality assurance group that's having to work a lot more because you didn't do testing, and then you apply, you know, then you do more test-driven development,
There,
and then you save them time where they don't have to come up with a stupid bug. You know, they
You know
don't find a stupid bug.
you know the guy I'm thinking of. I can't think of his name, but there's a guy that is of the opinion that the QA department should question why they are there and why they have jobs. And I tend to agree with that. I mean, there is a certain amount of QA that's necessary. I understand that. We live in the real world. But the code we write shouldn't be by default buggy. Bugs should absolutely be the exception rather than expected. And the QA should have very little work to do. And when you don't have tests, I mean, you know, our project that we worked on, we had a QA team of 2 or 3 people that getting deployments rolled out was very, very slow because they had this process of going through the application to find things that were wrong that we could not protect ourselves against because we didn't have code or code testing. But I do think testing will reduce the need for QA. Absolutely.
In an ideal world, the QA team just writes the documentation for the users. They have gone through everything and said, okay, everything works, and here's how, and then
Yeah.
they,
Well, ideal, yeah.
that would be the ideal world. That means we have created our tests that takes care of
Unless you
90%.
be more focused on testing the business logic applied as opposed to testing.
I'm more of that opinion.
Yeah, acceptance test.
Yeah. So there's two videos that I want to leave y'all with. Let's see, the magic tricks of testing Sandy Metz. Oops. No, this one anyways. So RailsConf 2013. A lot of the points that I made tonight, she has made much more succinctly. This is a video well worth watching. And then, let's see here. Software development. Did I put it in here? Yeah. And then test-driven development by Uncle Bob Martin. He goes in this episode of Uncle Bob. I want to meet this guy. I want to meet Sandy Metz, Uncle Bob, Martin Fowler, Eric Evans, and I'll just be shaking. I'll be shaking and jittery. But this one, test-driven development by Uncle Bob Martin, he goes and basically builds a scoring system for bowling, and he does that with TDD. And he also talked. This is about a 2-hour talk, and he talks about his opinions about professionalism in testing software, and he starts with that and then shows you how he does it in, I think, Java. And this is also a really good video to watch. I'm of the opinion that the only reason you shouldn't be writing tests is because you don't know how. And if you don't know how, then you need to find out how. Because I like sleeping at night. I hate getting woken up. And once I started writing tests, I started sleeping at night.
Excellent. Thank you very much.
Yeah, Josh.
Awesome.
Also, thanks to Gene for the food, man.